All right, so what if we're asked to find the cosecant of 7 pi over 3? And we're going to assume that we're using the unit circle and not a calculator to do this problem. Well, typically we would, let's just say we draw out, a little circle here, and all right, so we have a circle. Where is it on the unit circle? Well, 7 pi over 3 is typically not on there directly. So how can we locate this? One way to do it is to find an angle that is coterminal with 7 pi over 3. So 7 pi over 3, let's add or subtract 2 pi to that to see if we can get something that is on the unit circle that we've written down. So what I'm going to do here is I'm just going to subtract 2 pi from 7 pi over 3. So that would be 7 pi over 3, and then minus, all right, so 2 pi, that would be equivalent to 6 pi over 3. We'd have to get a common denominator there. And then, so that we have 7/3 minus 6/3, and so we get pi over 3, or 1/3 pi. So 7 pi over 3 and pi over 3 are both coterminal, which means that if I were to draw this out or sketch it out on the unit circle, they're going to land in the same location. So let's say I'm right here. Pi over 3 is about right here, right? And so then I'm going to draw that. And then hopefully I will remember and then can say what the terminal point is of pi over 3. So this is, I'm going to go over to the right 1/2, and I'm going up √3 over 2. So the cosecant of 7 pi over 3. Now in reality, the rotation is actually from here, and it goes around once, and it goes around again, and then that's where the angle is, right? But just to locate, if you're having trouble figuring out where 7 pi over 3 is, just find a coterminal angle with 7 pi over 3. So we can add or subtract 2 pi to it. Now, once we have the point, then we can just use our trig definitions for the cosecant. So the cosecant 7 pi over 3, if we look back to our unit circle, that's going to be the reciprocal of the sine value, or 1 over y. So in this case, the y value is √3 over 2. So really all we're doing is, what's the reciprocal of √3 over 2? Or if we wrote it out with this definition, it would be 1 over √3 over 2. And then if you were to take this and figure out what that is, right, you'd have to multiply by the reciprocal, which is essentially just flipping √3 over 2 to change it to 2 over the square root of 3. So our answer is 2 over √3, but since we can't have a square root in the denominator, we're going to multiply by the square root of 3 on the top and bottom just to clean things up. And so our answer would be 2 √3 over 3 for that answer. And there it is. All right, so let's try a similar one. Right, so this one says evaluate cosine of -135 degrees. Well, again, we're going to assume that we're not going to just use a calculator, and we're going to use a unit circle. And so I like to do here is just kind of sketch out, right? Just kind of draw a unit circle and draw the angle. So here's a circle. Ooh, that was a bad circle. Let's try that again. Ooh, that was another bad one. Let's see if we can do better. That was still really bad. Ooh, really bad still. Ooh, that was better. All right. All right, so we got a circle, and we got to figure out where is -135. So Where's negative 135? Well, you can just kind of say, well, a positive 135, if I'm going in this positive rotation, would be going up and it would be over here. But negative 135 is not directly on the unit circle. Well, we can just use our, we could just rotate the other way, right? And we could say, well, it's negative 135. So if I go down and I rotate the same amount, it is going to be over here. And so some people can just say, well, positive was up and to the left in that second quadrant. If I go negative, it's going to be just in that third quadrant as if I rotated the other way. But so in that case, again, you can figure out where it is, but you can also just find a coterminal angle with negative 135 to make sense of the problem if you're a little bit unsure. So I could just take negative 135, and if I were to add or subtract here, in this case I'm going to add one rotation to it, and since I'm working in degrees, I'm going to add 360 degrees. So if I take negative 135 and then I add 360, I would get 225. So 225 degrees. So again, negative 135 is coterminal with 225 degrees, because if I add 360, I'm not going to be changing the direction it's facing. They are coterminal. So again, whether that be this rotation right here, here's negative 135, and here's 225, just this way. In our case, since we're finding the cosine of that angle, if we use coterminal angles, it doesn't change anything about where we draw that angle, and therefore it doesn't change the point, the terminal point that's on the unit circle, which we're going to use to answer our question. So again, this question of where is, or if the angle is not on the unit circle, well, we just have to figure out which one it's coterminal with, and then draw the angle like that and get the point. So anyways, we need the terminal point on the unit circle, and so there it is, and this is going to be a reference angle. This is going to be a 45-degree reference angle. This is going to be the point negative root 2 over 2, comma, negative root 2 over 2. There's the point. And so, since the cosine of any angle, if we're using the unit circle, is always just x. The x value here is negative root 2 over 2. So our answer to this is simply negative root 2 over 2.